Now in the introduction we saw the divider-chooser method, and this was for 2 people, okay? But there's all kinds of iterations for many peoples. Now the divider-chooser method, like we saw, is nice. It guarantees everybody has their fair share in their own eyes, and it's a nice easy thing to, it's a nice quick way to do. Everybody kind of understands it and can move forward and do things with it. So here's what we're going to do. We're going to take the divider-chooser, but instead of doing it with, with 2 parties, we're going to increase the number of parties that have a stake in the claim. So, for instance, take me, my brother, and my sister. We have 3 people. How would we divide things up? And remember, we want a system which gives at least a fair share to each party. And it turns out there's a lot of different ways to do this. All right, so the first method we're going to look at is the lone divisor method. Now, we're going to do it with 3 people, so it makes sense. So there's me, my brother, and my sister, okay? So what's going to happen is one party is going to be given the loot and said, divide this into equal portions. Now, just like we saw in the divisor-chooser method with 2 people, what you're going to do, what you're going to be sort of promoted or compelled to do, is to divide these in thirds from my point of view, okay? Because the brother and the sister are going to pick 2 of these piles. Now, it wouldn't be fair to let one of these people go first. So it wouldn't be fair to let the brother pick one of these piles and then the sister pick another one, because the sister may have valued this pile at, let's pretend, 60%. And so if you let the brother go first and they pick that pile, then obviously she doesn't get her fair share. So what happens is they do a bid. And let's just assume these piles are called A, B, and C. So what each person is going to do is the brother is going to say which piles he's comfortable with. The sister is going to do the exact same thing, and they're going to do it anonymously. Okay? And it turns out the vast majority of the times, what's going to happen is the brother is going to pick, let's pretend the brother picks 2 piles. The brother picks A and B. Now, if the sister picks anything, all right, let's pretend the sister picks pile B, then what we can do is we can give the sister pile B, and obviously the brother therefore will get pile A. Remember, the brother said pile A is worth at least 1/3 of the total. Sister said, I only want pile B. That's the only pile that I think that's worth 1/3 of the total or more. And then obviously I'm here and I get C, which I think is worth 1/3, so I'm all fine and dandy. So if either the brother or the sister, if either of the other 2 parties picks 2 piles, then we're good. In fact, even if both pick 2 piles, okay, if the brother picks A and B and the sister picks A and B, well, I'm stuck with C, and it really doesn't matter. Give the brother A, give the sister B. Or if you wanted to, give the brother B, sister A. Okay? Everybody's going to walk away with a fair share. Now, the only case that we have an issue is when we don't get that. So let me pretend just for a second. The only case that we have an issue, again, if the brother picks B and the sister picks C, no issue. Give them the piles. But the only case we have an issue is when they both pick B. Okay? So here's what happens if they both pick B. What they're going to do is they're going to come together and they're going to say, well, we both like B. And they're going to be a little bit of a standstill. But what they're going to do is they're going to say, okay, which one do you think is the least desirable out of A and C? And the brother may pick C, say, yep, that's least desirable. The sister is going to come and so this is going to be a joint decision. So jointly they decide which is the worst pile. Let's pretend they say C is the worst pile. So what's going to happen? Well, I'm going to get C. Now the pile's gone. And now what happens is that A and B get thrown together. A plus B. And then the brother is now going to redivide this. So A and B get thrown together, and now you're going to do a divider-chooser method. And obviously this might be divvied up very differently, but you still a divider-chooser method guarantees fair share between these two. Okay? Now again, that took a long time to explain, but basically one person divides, the other people bid. If there is a way to divvy things out, we're done. If there's not a way to divvy things out where everybody gets their fair share, then you give the least desirable to whoever divided it and do another divider-chooser method with just two people remaining. All right? Now, if you have more than 3 people, then it's going to be pretty much the same things. All right? So, let's pretend we have, I don't know, there's me and a lot of different other people. Okay? So I'll call person 1, person 2, person 3, person 4, person 5. So, here, there's me and these 5 other people. So what do? I divide this thing into 6 piles. Now everybody bids, except for me, obviously, because I'm the one that divided it. And if there's a way to give the loot out, then we give it out. If ever a tie occurs, then those people give away like the least desirable options, if there's, the options that are remaining. And you do a divider-chooser for everybody else. Now, in the worst case scenario, you have to do one divider-chooser method. Let's say everybody picks the exact same pile. Well, I get thrown out, and now you do another lone divisor method on the remaining 5 people. And again, at each iteration, at least one person gets thrown out. So this is a finite process. Whoever divided it always gets thrown out, at least. Okay? But most of the times when people bid, there's a lot of different methods, a lot of different ways to divide things up. Okay? Now what you're going to have to do is you're going to have to look at like a table of bids and decide, what are different ways to divide things up using the lone divisor method. Okay? And is this a fair share? Is this not a fair share? Those kind of questions. So we're going to look at the lone chooser method now. And again, we're going to do this for n equals 3. And what's going to happen is this. So the lone chooser method, there's going to be a person at sort of the back of the line. I'll claim that I'm at the back of the line. So there's me. And so what's going to happen is there's going to start out 2 people. So a brother and a sister, let's just say. And they're going to do the divider-chooser method. So maybe the brother divides and the sister picks. And now there's 2 piles. Okay? And so there's two piles between them. And then what they do is they split things into what they see as thirds. And then what I get to do is I get to sit back here and I can say, well, that's the best third for me from my sister's pile. And that's the best third from me from my brother's pile. And this method also guarantees that everybody will get at least 1/3 of the goods. Okay? Because if you think about it, the brother is going to be left with two piles, this one and this one, out of 6. So 2 out of 6 is obviously 1/3. The sister is going to be left with 2 piles out of 6. And remember, they did a divider-chooser method, so they believe that these two amounts of good are at least 50%. And because I get to pick 2 piles out of 6, and I get to pick one from the brother and one from the sister, I'm guaranteed that I get at least 50% of the goods in my own eyes. Okay? So that's basically what's happening with the lone chooser method when there's 3 people. Now when you increase it, basically it's exactly the same thing, except here's me at the end. Let's say we have 5 players, or 4 players. Okay? What's going to happen is that somehow these 4 people are going to decide to split up the goods. Let's just say they do, other divider-chooser methods. Okay? Let's say they do the lone divisor method. And they're going to have 4 piles. So we're going to have 4 piles, 1 pile each person. And then what they do is they split this up into 5s. All right. And then I get to come along and say, well, I like this pile from person 4, and I like this pile from person 3, and I like this pile from person 2, and I like this pile from person 1. And all of a sudden, everybody has 4 slices out of 20. Okay? And remember, 4 out of 20 is the same thing as 1/5. So everybody has 1/5 of the goods at least. All right? And since we did this using these divider-chooser methods, basically it's going to guarantee that everybody has at least their fair share. Again, in their own eyes. Now, the last type of divider-chooser method is called the last diminisher. Now, this is a little bit different than the previous ones because the previous ones were more divider-chooser. Here, it's kind of a slice off. So here's what we're going to do. We're going to start with a list of parties. Let's say my brother, my sister, and me. And this list has to have an order. So I'm going to start with the brother, sister, and then me at the end. Okay? So here's what's going to happen. The first party takes a pile of goods. So let's pretend we have this huge pile of goods. So what happens is the brother says, well, I'd be comfortable with this much. All right? And it's going to be into his favor to actually pick about what he thinks is 1/3. Now, he gets to go first because he's first in line. Now, the next party either passes on the pile. They say, you know what? That looks like less than 1/3 to me, so I'm perfectly comfortable with you taking it. Or what they say is well, that looks like a huge amount. So instead of that pile, maybe my sister cuts it off and says, well, I'll take a little bit less than that. and I think that's a third. Okay? And then I get to come along and say, again, the same exact thing. I either can say, well, that looks like less than a third to me, so I'm okay with my sister taking it. Or I get to cut a little bit off. Let's say I cut this off. And claim the pile for myself. So basically, it's this sequence. And if we had 90 people, then we'd give 90 people the option to either pass on the pile or to cut it off. Now, I want to point out something. If my brother claims this pile and my sister passes, she does just pass herself, okay? So I still have the option, to cut off and throw off my brother and say, claim that pile as my own, okay? And by the way, I also have the option to pass. So if my brother claims this amount, if my sister passes and I pass, then my brother gets it, and then my sister and I are doing the same thing on this. Okay? And so you start over, so after, let's say my brother wins this pile, that pile's gone, and now my sister gets to cut and say, well, I think this is 1/3. And I either can kick her out of that pile, or she thinks it's 1/3 of the total at least, or 1/2 of the remaining. So I can either kick her out of the pile or cut a bit off and claim it for myself. So the process just keeps going on and on and on until all of the parties are done. Okay. So that's the last diminisher method. And if everyone's being fair, meaning if everybody, isn't trying to game the system, if everybody is actually looking for 1/3 of the loot, then the last diminisher method will give everybody their fair share. Okay? Now, here's the main disadvantages and advantages of all of these. Okay? The main advantage is that in every one of these methods, all of the parties are getting their fair share. Now, the disadvantage is that there's a better position to be in. It turns out it's always best to be in the last, or the choosing position. Okay? It's always best to be in that position. Because think about, for instance, the last diminisher method. Okay? If I'm in the last position and I see a pile that I like, I can cut off a really, really tiny segment and take, whatever the pile, basically almost all of the pile. So I can always cut off a really, really little bit. Okay? So it's always nice to be in the last, or in the choosing place. Okay? So if there's the lone chooser method, it's better to be that lone chooser. If there's a lone divisor method, it's actually better to be one of the choosers. Okay? So that it does give one party a little bit of an advantage. And the other disadvantage is that, well, what if we have something like a house? And obviously, you're not going to be able to cut up a house. And oftentimes, if you have items, like for instance, if somebody passes away, they'll have like a house and a car and a little bit of money. And obviously, the house might be worth vastly more than all of the other items combined. So it's a real hard thing to divide up a house and a car, two people. Obviously, whoever's going to choose that. If it's a good house, you're going to take the house. Okay? Again, if the house is much more expensive than the car. So it's sometimes hard to divide into piles that are actually 1/3 or 1/2 or 1/4. Okay? Especially if we have a real big ticket item. So that's, again, two advantages. An advantage is obviously everybody gets their fair share. Everybody understands those games. And secondly, the disadvantage is that it's always better to be in the choosing position. And it's sometimes hard to divide things into piles, especially when we have really big items.